Welcome to the first lesson on hypothesis testing, and this is going to be the start of a series of lessons on this particular topic. Okay, so first of all, what we want to try and achieve in this video is to understand and apply the actual language that we use and associate with hypothesis testing. So, at certain points of this video, you might want to pause and make some key notes on some of the statements in order to help with your understanding. So there are quite a few specialist terms that we actually use in association with hypothesis testing, and you really need to gain an understanding of what each of these means. So first of all, then we look at the word hypothesis, and you might have come across this word in the past, particularly in a science lesson, and this is a statement which can be an assumption or a claim about a certain value of a population parameter. We can test a hypothesis about a population by carrying out an experiment or taking a sample from the population. The assumption may be true or false, and the hypothesis testing is a procedure that allows us to determine whether an hypothesis should be accepted or rejected. So, for example, we could want to try and check to see whether a coin is biased in any way. So we might carry out an experiment and throw the coin a certain number of times and see what the results are in order to make a sort of conclusion on whether it is actually biased or not. Okay, so that's what an hypothesis is. So the parameter itself then is a certain characteristic that we can use to describe a population. The parameter used in this topic will always be called the probability P, okay, which is the probability of success of a single trial. Okay, so there are two types of statistical hypothesis that we'll be working with. The first one is called the null hypothesis, which is given using the symbol H with a suffix 0, and is the hypothesis that we assume to be correct. And against this, we need a second hypothesis, which is called an alternative hypothesis, and this is given the symbol H with a suffix 1, and this tells us about the parameter if your assumption is shown to be wrong. We need to form these two hypotheses when we're setting up a hypothesis test. And the test statistic itself, in order to test whether an hypothesis is true or false, okay, whether we can reject the null hypothesis or not, we need a test statistic, which is a statistic collected from the result of an experiment, or the statistic that is collected from a sample data to see whether the null hypothesis we reject or not. Okay, so that will only come from the data that we gain. Okay, so example number 1 then. Okay, in this particular case here, John wants to see whether a coin is unbiased or whether it's biased towards coming down on a head. Okay, so he tosses this coin 8 times and counts the number of times X that it lands heads uppermost. So we're being asked to describe the test statistic, and the test statistic this time is X. So the test statistic is X, which is the number of times the coin lands on a head. Okay. So a suitable null hypothesis. Well, what do we actually know about a fair coin coming down on a head or a tail? Well, the probability of that would be 0.5. So to set up a null hypothesis, so this is our null hypothesis, the probability, which is our parameter, must equal 0.5. Okay, so you must always write this down in this form. Now, a suitable alternative hypothesis, we would write down the H1. So this is our alternative. Now, in this case, we're going to say that P is greater than 0.5 because John thinks that it's biased towards coming down on a head. That means if it's biased, it's going to land on a head more than it will a tail. So the probability then, P will be greater than 0.5. So here is the null hypothesis for this experiment. Okay, and that's pretty much the nuts and bolts to setting up hypothesis testing. Okay, example 2 then. So in this one, we've got a four-sided spinner, which has got the numbers 1 to 4 on, and it's used in a game. Jack suspects that the spinner is biased in favor of the number 1. So he thinks it's going to land on the number 1 more than the other 3 numbers. He wants to perform an experiment to test if the spinner is biased towards 1. He spins the spinner this time 10 times and records the number of times it lands on a 1. So this time our test statistic is going to be the number of times the spinner lands on the number 1 in 10 spins. So X is the number of times the spinner lands on a number 1 in 10 spins. Okay, so that's what the experiment is about. So we're going to write down now a suitable null hypothesis. So again, we're going to need to set it up, H0. Okay, now if this spinner was a fair spinner, then the probability that it would land on a number 1 would be equal to 1/4 or 0.25. So there is our null hypothesis. Now our alternative hypothesis, okay, in this case for P, we think that it's biased towards the number 1. So if it lands on the number 1 more than what we would expect in a fair test, then the probability is going to be bigger than 1/4. And there, for this question, is our null hypothesis. Now, that's how we set the hypothesis up for a particular test. Okay, so hypothesis that come in the form here, like we've just seen, H1, where P is less than, for example, a half or a quarter, or we could sometimes see that P is greater than half or a quarter, for example. These are called our one-tailed tests. But an hypothesis test, which has an alternative hypothesis in the form, for example, H1 is where P is not equal to 0.5. So it means that P could be less than 0.5 or greater than 0.5 are called two-tailed tests. Okay. So to carry out an hypothesis test, we assume the null hypothesis to be true and then consider how likely the observed value of the test statistic was to occur. If this likelihood is less than a given threshold, called the significance level of the test, then we would reject the null hypothesis. Typically, the significance level for a hypothesis test will be given to you, okay? It'll either be at 10%, 5%, or 1%, but you will always be told what the significance level will be. So, here we have a final example where an election candidate believes she has the support of 40% of the residents of a particular town, and a researcher wants to test at the 5% significance level whether the candidate is overestimating her support. So the researcher asks 20 people whether they support the candidate or not. Now, 3 of these people say that they do support the candidate. Now, we are being asked to write down a suitable test statistic, okay, for this experiment. So the test statistic here, again, we can call this X, is going to be the number of people who say they support the candidate. Okay, so there's the test statistic. So in this case, we know that's 3 people. So we need to now write down 2 suitable hypotheses. Okay, so we need the null hypothesis. So she believes that she's got 40% support. So in this case, P will equal 0.4. And the null hypothesis, the alternative hypothesis, sorry, because we think she's overestimating her support, then the actual support will be less than 40%. So the null hypothesis will be a one-tailed test where P will be less than 0.4. Okay. Now, for part C then, now we're being asked to explain the condition under which the null hypothesis would be rejected. So in this case, all right, the null hypothesis would be rejected if the probability, so we reject, I'm going to call it H0 for the null hypothesis, if the probability of 3 or fewer people saying that they support the candidate is less than 5%. So that's the significance level of the test, given that P is equal to 0.4. Okay, so we're testing to see whether the actual probability is less than 0.4. So we would need to calculate the probability in this case. And that's something that we're going to look at doing in future lessons. Okay, so what I would like you to do now is I would like you to have a go at this main task. So you're going to need to pause the video and have a go at those questions there. Okay, solutions to those for you to check over your solutions soon. Okay, once you've done that, press play and have a go at the checking question. Okay, so pause the video now to have a go at the main task. Okay, welcome back then. All right, just a quick checking question then for today. So we've got this scenario where John thinks a coin is biased. So he's going to conduct an experiment using 100 tosses of the coin, and he's going to record the number of times that the coin lands on heads and tails. Okay, so we're going to write down a suitable null hypothesis that he could use for this coin. So the null hypothesis, okay, so this is a recap then, okay, represented by H0, and P in this case is going to be equal to 0.5, which is the probability of a fair coin landing on a head or a tail. Now the alternative hypothesis, H1, this time it doesn't say that he suspects that it's going to be biased towards heads or tails. So the bias could go either way. So in this case, the null hypothesis would be P, the alternative hypothesis, sorry, is P not equal to 0.5. And the test statistic that we could use to check for bias here, well, the test itself. So the test statistics X is going to be the number of heads recorded from 100 tosses of the coin. Okay, or we could in this case use tails instead, because we don't specify either way. Okay. Thanks for listening to this video.